Hello.
Hello.
How are you this morning? Or whatever time zone you happen to be in.
It is this morning, yes. I'm doing okay.
Great. So, my name's Ken, and you can be anonymous or whatever.
Okay.
How many of these have you done?
This will be my first one.
Okay, good. It's been my first one with interviewing.io. I've done a bunch of coding technical interviews, but this is the first time I'm actually working with this thing. So,
okay. So we'll muddle through it together.
Yes, it should be reasonable practice.
All
right. You can use the language of your choice.
Okay.
My language of choice is Ruby.
Hmm.
But don't let that muddle you. I'm fluent with almost everything.
Okay. I will probably use JavaScript.
All right, then. All right. So I'm going to paste. Let's get started. I'm going to paste in this thing. You've probably seen it 1,000 times before. And let me change the language for you.
Okay.
That way I can. Good. It commented it. Cool. I don't know. Have you used CodePen or CodePoint or any of these other interactive things before?
I've used a couple, of these little online IDEs. Yeah.
So, all right. So, there's no rush.
Okay.
Let me tell you what my expectations are, and while you're reading, this is not a trivia test. I am not looking to see whether you know the difference between O log n and O n log n or whatever. The better analogy is, have you ever heard of a cardiac stress test?
I don't think I have, actually. Oh.
Okay. Well, let's say that your doctor thinks, let's see if your heart's okay. And one of the best ways to do it is to put you on a treadmill, wire you up to some electrodes, maybe put a mask over your face to measure the air volume, and then start slow and watch how your things go. Now, a really bad thing would be is they actually triggered a heart attack while you're doing the stress test. That is not my goal.
Okay.
I've got
a bunch of that.
I know my goal is for once you feel comfortable is to kind of by using a bunch of different pro points that I've got on my checklist over here on the side that you can't see is where your comfort range is and your technical limits.
Okay.
So there are no right or wrong answers.
Okay.
And I am much more interested in hearing how you solve problems than actually solving the problem. But that being said, have fun with the problem. Go wherever you want to go. I will try to keep you out of the weeds if you get stuck, and so that you don't get frustrated. And I will also try to help you where I can. But don't worry about whether this stuff is performance or not.
Okay.
What I want to see is solve the problem first. I'm a TDD agile type of person, so the first rule is to make it work and then make it right and then make it fast. And so we can talk about this stuff. It depends on how fast you get through this. What the levels of stuff that we can talk about. But this is your chance to show off, your chops, and I'm going to try to put you through your paces as best I can without causing a heart attack.
Okay. So, I'm actually not familiar with this problem. I have not gotten it yet, so let me just read through it here first. So, your task, should you choose to accept it, is to implement LRU Cache. LRU caches are often used to implement caches which you do not want to grow indefinitely.
Yeah.
The cache
So,
has max size.
so LRU, I'm going to fix this. LRU, so this is the least recently used cache.
Okay.
Right. So the idea here is that you've got a bunch of stuff in a bag, but the bag has a limited capacity, and that when you put something new in, you want to evict the oldest thing from the cache, so that they're always the most recent stuff is always in the cache, and stuff that's gotten old has fallen out of it.
Okay. So it sounds kind of like a queue type of, first in, first out type.
True. Yes, but it's random access.
Okay. Okay, so the cache has a max size, and when the new key is inserted, that will make it grow larger than the max size. The key which has not been accessed for the longest time is removed to make space. So it should support these operations: get key, get the value of the key if it exists in the cache, put key, update or insert the value if the key is not already present when the cache reaches its capacity. It should invalidate the least recently used item before inserting a new one. Okay, so what happens if you call get key on a key which doesn't exist in the cache is up to you to define. Okay, so these are the operations down here. So we have a cache, a new LRU cache with a capacity of 2. We'll put 1 into okay, so these are the keys and the values. Okay.
Yeah. So this shows you what I'm highlighting, right?
Yes.
Okay. Yeah. So that's the key and that's the value.
Okay.
So this is a great tool for performance improvements, like web things, right? Where you get a page, your browser gets the page, and then it gets another page and gets another page, and then somewhere along the line it says, you haven't looked at this page in like a week. You're probably not going to look at it again. I'm just going to throw it out of the cache to make room for the next web page that you need, or vice versa. So that's why it says get 1 is the key. Get 2, get 1 is going to get what the value was, which in this case was the string 1. These values and types don't really matter. So here on line 23, where it says put 3, right? It's going to put a new value into the cache, but there's only room for 2 slots because of the capacity 2.
Yes.
So it says, all right, well, we're going to get rid of this one because get refreshed the recency of that particular key.
Yes.
So 1 gets to stay a bit longer, 2 gets kicked out, and then kick out. So this is this here where it says returns null because 2 is ejected. That's where you get to decide whether it returns null or an exception or something else. That's up to you.
Okay.
What you want to do there. And again, so here, right? You put this is the 4th key goes in. So 1 gets kicked out because you get 1, get 2. Now 1's gone. Now you get 3, you get 4, and so in the cache at the end are keys 3 and 4.
Okay. Okay. So I'm going to be creating a new class called LRU Cache. So I can start with that first. LRU Cache, and it will have a capacity property. So it will need constructor class. Yeah. Then we'll need put and get methods to it.
Mm-hmm.
And so each method they'll need a key and a value.
Mm-hmm. No, the get only needs the key.
Oh, yes, you're right.
I'm also here. I'm also here to be your wingman.
Okay.
Yeah. So I'll try to keep you from falling
Making
off the rails.
dumb mistakes. Yeah.
Yeah. I'll catch you on the typos and stuff because that's
okay.
you're not really being scored on grammar.
Yeah. So we need a capacity. We also need some place to store these keys and values. So we need our actual cache.
Mm-hmm.
So, and I think so. I also need somewhere to record when something was last accessed.
Mm-hmm.
So I'm wondering.
Yeah. Okay, go ahead. But what I was going to suggest is that if we simplify the problem at first, will that help with the design choices? What if we said that this was an unlimited cache, that it basically, it's a dictionary, right? You put stuff in, you get stuff out, right? And would that make at least your initial design choices easier, and at least simplify it for testing?
Yeah. So if it was an unlimited cache, that would probably just go with. I mean, you would just need an object to store the keys and the values.
Yeah, exactly.
Okay.
And I'm big on testing and getting feedback from my code. So one of the things that I kind of like to see is, hey, does this stuff really work as you're going along? And what little things can we put into the interpreter to say, all right, hey, it works. It doesn't work. It doesn't work as expected.
Okay. So let's see. So if it was an unlimited cache, then we could just, in this class, just have the cache object and put would just add in. So this cache, the key equals the value. And I think and we want to return.
So puts are undefined. Yeah, it's undefined what put returns.
Okay. So the big important part's just that. So a get, we want to make sure we return this .cache key.
Yeah. Okay. Can we see this work in real life?
Yeah. So right now we have cache new LRU cache 2, and if we do cache put 1 1 and then cache get 1, it should return us 1. And now cache is not defined because I need to declare it.
Yeah. Let's.
Do I need to
Yeah, you need to put a console. Yeah,
okay.
or if you just take that code that you've written and copy and paste it over to the right-hand side, That's the interpreter.
Oh, okay. This guy.
No, you can leave that there, but just the last 3 lines.
Oh, okay. So const cache equals new. Let's just console log this, see if it just gives us what we want. Run.
Yay!
Okay. So we got our 1. All right, so we can put in and we can get items from the cache. And so now we need to check and see if the cache is at or over capacity. Well, it should never go over capacity.
Yeah.
So so we need a conditional to check if the cache is at capacity. So if this cache, oh wait, so what was it? I think I'm looking for object keys, this cache length equals this dot capacity, then we are at capacity. Else. So just a quick check here to make sure that this logic is working. So cache put to 2, and we've got our cache get 1 there. And let's do console log cache put 3. Need one more parentheses there. Okay, so we got 1, and we got the we are at capacity. Okay, so when we are at capacity, then we need to throw away the least recently used item. And that's, so we need to record the last time that everything was accessed. I'm wondering if that should be like a separate object that has the keys and the value is the date last accessed, or if there's a way to do that within the cache object.
Either way works for me.
Okay.
In terms of implementation, I'm easy.
Okay. So yeah, my first instinct is to go with a little object here, this last accessed, and so it would do this last accessed key equals, and I think it's like new date. I believe that's the current time in JavaScript. Let's
ta-da! Yeah.
Okay, so that's new date, and so that will give us our, actually, let's just make sure that this last accessed, let's run that and see if that gives us the object we're looking for. Okay. So those are, yay. Are those times subtly different? It's hard to tell with this.
Yeah, it's gonna be tough.
Yeah. Like milliseconds difference or something.
Yes.
Okay.
That's an interesting design question, right? What if this thing is being pulled so fast that even millisecond granularity is not enough?
Yeah.
Or does it matter, right? The Yeah, I mean, the trouble with does it matter is that it makes your testing unpredictable.
So we do need to, on the get, we need to update that last access. So
yes, we do.
This dot last access t equals new date. And that should subtly change the times a little bit, maybe. Yeah.
Maybe can we put a sleep in? Does sleep actually work?
And we could like set timeout, maybe.
Oh gosh. Oh well. All right. Yeah. Asynchronous things. Let's not make our lives miserable.
Okay. I think it'll still eject the right ones here. So we have our table of last accessed. We now need to go through that table and find the one that is the oldest date. And I'm sure there's more elegant ways to do this, but just brute forcing it, my first instinct would just be to loop through all the keys and just compare dates.
Like I said, I'm not looking for elegance at this level. So just let's get something that works and comes back with reliable results.
Okay.
And then if we have time, we can talk about refactoring and optimizing and other things. But yeah, so good call. Yeah,
so
force it, man.
We'll do this ugly, and it will hopefully work.
Yeah.
All right. So object dot keys this dot last accessed. For each, we have a key, and we're gonna do some things to it. So we need let oldest key equal nothing at the moment. So oldest key here. So start undefined, and we'll have some logic in there. But if the oldest key doesn't exist, then we'll just say that's the key. Oldest key. So if key, all right. So if this last accessed, okay, this ternary is going to become kind of a pain in the ass. So let's just do an if statement, just because. So if oldest key, we'll do some logic there. Else, all my tabs are screwed up.
Yeah.
Oldest key equals key, and I'll fix that because I like pretty code. Okay. So if oldest key exists, then we want to compare oldest key, this dot last accessed oldest key. If it is, if we want to see if it's less than.
Yeah, they're smaller as they get older.
Yes.
Or they get
so
bigger as
less
they get
than
older.
the last accessed key, then we will stick with the oldest key. So oldest key equals this last access, so oldest key, otherwise key.
Makes sense.
And So at the end of all that, here, let's get rid of these guys. We don't need them anymore. So at the end of all of that, we should have console log oldest key, which should be 1 in this case. So let's run that and see what we get. No. So we are not getting the right key here. Okay, maybe I should actually, since I'm accessing each key already, let's just console log this last accessed key just to see what those times are.
You might it might help me. It might help you if you put some labels in on those console logs as well. My memory stack is only about 5 plus or minus 2. So I know what these values are, but I can't remember which console log statement is here and here.
Sure. Okay. So let's see here. We got our.
Yeah.
Actually, for the get, instead of just returning, I'm gonna console log the value at key is this cache key.
Ooh, that works now?
Yes.
Whoa, I learned something new today.
Yes, template literals are my friend. Okay.
Yes.
All right. So that is, let's see here. So let's add some labels to this one. The time key was last accessed was this last accessed key, and I need to turn that into a backtick. Okay. And the oldest key is but not really.
Or not yet.
Yeah. Okay. So I think, the issue is that because this is all happening synchronously.
Actually, I think that's the right answer.
Oh yeah, no, that is the right answer because we accessed 1.
Yes.
If we took this guy out.
Yep.
Then it still doesn't work.
Try instead of putting that out, change it from. Oops, what did I just do? Oh, it's undoing my thing. Try replacing get 1 with get 2.
Okay.
And see if you get a different
get 2.
result.
Okay. Yeah. So now the oldest key should be 1 by far, and it is not. Okay.
So maybe date or timestamps is not a fine enough granularity for this task.
Yeah.
We need to come up with some other data structure or algorithm for solving it.
So let's see. This is the last accessed.
Let me try to. Okay, I'm going to make a suggestion.
Sure.
Just to maybe this will help, maybe this won't. If it doesn't help, just tell me to F off. All right.
Okay.
So the getting of cache keys you got working just fine. And we have sort of and it looks sort of like a method or some kind of API for recording the last, although right now we're doing date. It's this algorithm that's causing pain, right?
Okay.
Can we just take that whole algorithm out and make a brand new method which just says this is the key that you need to evict before you do the next put?
Okay.
That might in one way you can start test driving just that small piece of the code and leave the rest of it alone. And it also might help with data structures if you can separate it out into something. It may actually turn out to be harder, but my instinct says let's figure out let's create a different function to figure out what's the key that we should evict next.
Okay. So yeah, we want kind of an evict method.
Yep.
And
it doesn't actually have to do the eviction, right? It just has to say this is the one to do, and then we can write separate code that just deletes the key.
Okay.
Right? So that's just to make it even simpler, right? That the only thing that just tells you which one's the oldest.
Okay, so this is actually find least used.
Yeah. Okay.
Okay, so what we want to do is if the object key's length equals this capacity, then we will want to use this find least used key.
Mm-hmm.
And that will return back, and it should return back the least used key.
Mm-hmm.
So that doesn't actually, I don't think that actually needs to take any arguments because it's going to just go through the cache. And so all of this in here will be a part of that. Let's see, find least used key. So let's just toss this in there for a moment. And then least used key is least used key. Okay. And let's just, for the moment, let's just return, this will be the least used key, just to make sure that that's running correctly.
Yeah.
Okay. All right, so now we've got to figure out the least used key here.
Yeah. So you had actually started down this path at the very beginning, which was this was going to be some kind of queue.
Okay. Yes. So if we have a queue, we have, so a queue could actually be an array. And so if we turn this guy into an array, then our put would be, so it'd be an array of keys. And we could push the key into the array. Now, if the key already exists and we're updating it, then that might be
right. So there's a little magic involved. Yeah. I mean, I like the path you're going. Right? So look for the key in that last accessed array. If it exists, then push it pull it out of wherever it is and put it back to the beginning.
Yeah. So it's probably not the most performative, but we'll start with that for now. Okay. So first off, simple thing is, let's assume the key does not exist. So this cache key equals value.
Okay. Right. I see what you're doing. Okay. I thought you were working on your algorithm.
Oh.
So I was trying to save you from editing the wrong block of code, but no, you are correct, and I will shut up now.
Okay. Let's see here. So we could actually, and I could probably put all this the logic of whether to push it to the end of the array or sort through it into a method itself, but
So it's going to be used twice. Yep.
Yeah. So let's see here. What would let's call that update use or something. Update.
Naming things is one of the hard things in computer science.
Okay. There. That is a complete sentence. Okay. So this dot lacks access. So the simple case is it just pushes to the end, and so this would be this update access time key, and this update access time key. So that just pushes everything to the end. Now, what we need to do is, and this is, so array, so this last access index of key. So if equals -1, then we do that. We push it to the end. Otherwise, we need to remove it from the array and then push it to the end. And let's see here. Let's see if I can remember my splice. Oh, they gave me a little help for there. Come back. So we have position and amount. Okay. So we want. I'm wondering if I can.
I'm going to just type over here in the console because I'm curious.
Okay.
But keep going.
Let's see here. So index equals this, since I'm going to be using this a couple of times in here. Index of key. So if index equals -1, index 1, and then we would push key. And let's just console log the last access array is currently, get my backtick in here, this last accessed. Okay.
And we can actually like experiment with that, right? Just to isolate on that update access time function to make sure that it's doing the right thing for us without having to run all the other bits and bobs. We can just focus on that one function for a little bit.
Yeah, so if we got the value here, and so if I just comment that out for a moment, and comment that out. So that's put, that updates the access time. And do I got any more consoles in here? Got this guy here. Let's just return true for a moment. Just get you simple. All right, so this should just show us the state of the last accessed array throughout these lines of code. So it's currently 1, 2. The last access array is currently 1, 2. And okay, so if we do that, then 1 should end up on the end of the array. Currently 2, 1.
Hey, sweet.
Now, Why aren't you doing something here? Let's see. Is it because you're console logged?
Yes, because put doesn't actually have any return values.
Yeah.
And put
should be doing. Should be running this guy one more time.
Unless it's this thing is not.
Yes, because it's at capacity. Okay. So when we get to capacity, we need to find the least used. And this guy is actually pretty easy now because he's essentially just returned this last accessed 0. If I'm not mistaken.
Mm-hmm. You might want to just shift it off while you're doing it.
Sorry, shift it off?
You this push, pop, shift, and unshift, and I always forget. So let's decide.
Oh, yes. Yes.
So left-hand side, the 0th element in the array is the most recent. And
yes.
So the oldest is going to be the end of the array. So if you use shift, I think, right?
Yeah, so I think, I want to, hold on, const least used equals, I want to get that before I shift it off. And then return least used. And after that, let's copy over, let's copy over this console log to see what our least used array is doing. Okay.
Yeah.
So that removes that. So I think we've taken care of all the removing, and now we just need to this cache key equals value, just basically repeat this, which means essentially all I really need to do is just not put an else here.
So how do you evict that old value from the cache?
Oh, yes. So, okay, so we need to, this last access used, and so we need to remove keys from the thing. So I think
Yeah,
delete.
You should do that. You want to do that in the put. But yes.
Okay, yeah. Find least used. So least used key is here, so we want to, yes. I think it's delete this cache key. Let's console log the cache is now this cache. Let's run this and see what happens. Oh, well, of course it's an object. But if we do, let's see, what was your things now? Get to, so cache get to, let's see what that does, and cache get 3. And my get is no longer.
Yeah, I need to do console logs.
Yeah. Okay, let's see. I think we got that guy figured out, and this is not actually useful. So we have the last accessed array. The value of key 1 is 1. The value of key 2 is 2. And so right now, get, if it doesn't find something, so this update access time key. So if this cache key, then we can do all that stuff. But otherwise, we need to return something. So if this cache key do this stuff, else console log.
Yeah, key not found.
It's not found.
Okay. Why is this getting 132?
132. Oh, So if it's at capacity, then we find the least used. Oh,
Does delete actually doing what we think it's deleting?
Well, and the array doesn't seem to be shifting. Why aren't you working? Let's see here. So this last accessed. So find least used, let's make that just, all it does is just return the thing. We'll shift it afterwards. So the least accessed array is this, and then we will do things to that. So this just returns this last accessed 0. And let me just run this real quick. Okay, so last accessed array is 1, 2, 3, 1. Value key 1. The last accessed array is currently, why is this not even running? Console log, last accessed array is currently, I didn't console log my least used key. Console log, the least used key is least used key. Okay. Least used key is 2. That is correct. And so this last access shift, okay, is 1, 3. So yeah, that is not, let's see, delete object key, I thought. That was right. Let's see.
Yeah, I tested that over here.
So let's see. Why are you not? So if this cache key
So you got rid of the else here, and I think that may have been what's confusing stuff. Because you delete it and then you add it right back in again.
Wait, this cache, this cache least used key.
Yes.
I think that's, I was deleting the wrong key.
Hey, there you go. Sweet.
Alrighty. So that is, so we are at, when we reach capacity, we find the least used key and we remove it.
Just 2, right? You get a not found. Yep.
Let's see. Are there any other cases we need to make sure we take care of here?
There probably are, but we're running low on time, and I want to stop here because we're a good stopping point.
Okay.
So how's it feel?
So that was less intimidating than I feared.
Yeah.
It was. I appreciated being able to just work through it, pretty much line by line, and figure out, how to build this thing up first with no capacity, and then adding in the capacity, and yeah. So I feel pretty good about it.
Okay. So I'm looking at my notes, and actually, so without rewriting anything, because we're kind of pressed for time, but now if we had a test suite, which would be like the next thing that I would work on, so that you could just run tests and say, hey, it's still working. I'm just going to do this in pseudocode, right? Equals undefined, right? This is, really pseudocode. Undefined. Hang on a second. Undefined. Well, let's say null. Assert equals 3. So now, if we had a test suite and this actually worked, right, we could run it and then say, and every time we made a code change, now we could say, all right, well, our code still works.
Yes.
Which would help in the refactoring part. But now let's assume that the test always works and that you don't break anything because you're a perfect coder. Where would you attack some refactoring choice? Okay, let's look at once you just kind of look at the code and say, where are some places where I could refactor this to make the code more expressive, make it fewer lines of code means fewer bugs, that sort of thing. And just pick you've been banging away at this for 45 minutes with your head down, and so I'm trying to get you're trying to get you to relax, take a breath, and kind of look at the code from a more global perspective.
I would probably, like, the put area could probably use some refactoring. So because the find least used is so simple now, it may not actually even be necessary. I mean, we're grabbing the 0 index of the last accessed array.
So because this is all one action, and shift in itself is destructive.
Yes.
So you could shift the value off, find it, and delete it all in one line.
That's right. Yes, because shift returns the value or the key. I think it returns. It returns it's an array. So it returns the value.
Yeah. So you could do this.
And then find least used is pretty much redundant at this point. It's not used.
Nice thing about this is that this is an almost atomic action now. Right? It finds it, it pops the thing off, it shifts the thing off the queue and deletes it all at once. So there's no it reads as this all happens at once, right? It's atomic. And it's easier. Right? And I like that you got rid of the else. I don't like else's. They make my brain hurt.
Yeah. and it was nice to just see, we're doing the same thing, regardless at the end, whether it's at capacity or not.
Yeah. The there's a design pattern where you're adding functionality to a class. So one interesting way to refactor this is to start with an infinite cache as a class, right?
Oh, okay.
Right, and then and I don't know how to do inheritance very well in a
so
right?
class LRU cache extends cache or something like that.
Yeah, exactly. Yeah. And then you could extend the functionality to do the evictions as you move along.
Okay.
Also, I mean, this one's super easy, and these are the same, right? So
yes.
you can take them out. You can take that out of the if and just kind of go.
Yep.
Get that out of there. Oops. Stop. Yeah. And then whatever. This is what.
So essentially, if the if does not equal, then that, and otherwise you just push.
Yeah. Yep. Super simple. Easy to.
I think we still need a push after 67, right?
Oh yeah, because I got rid of it, didn't I?
Yeah.
Oh, whatever. We're sort of done. Yes. All right. Cool. Have you done much testing in JavaScript?
I've done server-side testing, Node using Mocha. I've done some React enzyme testing as well.
I'm always curious about. I mean, like I said, for me in Ruby, testing is sort of it's sort of part of the DNA that I can load testing into the same editor as everything else and start running it. It's testing setting up in JavaScript still gives me pain.
Yeah, I don't think there's going to be any kind of I don't know if this particular interview setup has an integrated tester or not, but
it actually does.
It does? Oh.
It has Chai, Simon, and Mocha. Although there it is. That's how you get them. Cool. All right. Learn something new every day. Yeah. That is, I would say, a personal preference. That I try to drive testing first, and I know that I'm fighting City Hall on that.
I like testing first when I'm making endpoints on the server, at least. So I definitely want to be using testing first more in my code. Yeah, just because it lets me know if I'm screwing up.
Yeah, exactly. Okay. Time is up.
Okay.
Any questions or comments for me? And especially since it's the first time I've ever done this, I actually don't know what to do next.
Yeah, I guess we just end the interview down there. How's, as far as the flow of this interview, how does this compare to other interviews you've conducted, as far as working through the problem?
I think it worked well. You seemed a little shaky out of the gate, which is expected. But about 15 minutes in, you started to hit your stride on this stuff, and I was impressed by the way you started solving the problems, especially since when you started facing the the fact that it wasn't working, right? And
Mm-hmm.
you kept working at it. And my only comment is to make the outputs from your whatever you're doing, whether you're going to do testing or console logs, make them more expressive about intent.
Okay.
If you're not going to do testing, then put console logs in that say I expect it to be this.
Okay.
So because when I started looking at it, and when you got to about 4 or 5 lines, I started losing track of, is it right? Is it working? I don't know. I think it is. It sort of feels right. And I had to scratch my head a little bit. And if in the expression of the code that you're doing, you say this is what it should be doing, or this is the output I expect, compared with the output I get, even if you're not testing, then there's a very concrete way for the interviewer to say, yeah, okay, you're doing it right. And then at least and then one of the other things is that the interviewer can't say, well, no, you're doing it wrong. He says, well, no, I got the right answer.
Okay.
He says, you may not agree with the way I did it, but yeah. So yeah, and you used your outside voice all the time, which was great, because we're trying to see how you think. That is the number one high order bit for all these screenings, is to see how you attack problems, not whether you get the problem right or not.
Okay.
Well, thank you. It's been a pleasure.
All right. Thank you very much. Yeah.
Good luck with your job search.
Thank you.
Bye. Bye.